Here we'll be able to see some applications of the algebra functions, these operations, whether we're adding, subtracting, multiplying, or dividing two functions. In this example, the average number of email messages sent and received per corporate user per day in year T between 2011 and 2015 is projected to be f of t equal 3t plus 69, where t is between 1 and 5. And the average number of spam emails sent per corporate user per day is projected to be g of t equals negative 0.2t plus 13.8. And we want to find a function that would give us the projected average number of legitimate emails sent and received per corporate user per day in year T. So make sure we understand what the problem is telling us and what we're trying to find. That'll make things a lot easier arriving at the correct answer. All right, so they're giving us a function for the average number of email messages sent and received per user per day. And they're also giving us the average a function for the average number of spam emails sent per user per day. And what they're asking us to find is the projected average number of legitimate emails sent and received per user per day, right? So what is this legitimate email telling us, right? So this f of t is giving us all the emails that are sent and received per day, and g of t is the number of spam emails. And so if you were to take away the spam emails, then you would have remaining the legitimate emails, right? Legitimate being the non-spam emails. So if we want to find this function that gives us the average number of legitimate emails, what we can do is we can take the total number of emails and subtract the spam emails, and what we'd have remaining is the number of legitimate emails. Now, we're not doing this with actual numbers. We're just doing this with a function. We're just trying to find the function that represents the projected average number of legitimate emails. So we will take f of t and subtract g of t from this. So we have 3t plus 69 minus negative 0.2t plus 13.8. Now remember, in the previous video I said to be careful when you're subtracting. You need to distribute this subtraction sign. What that's going to do is going to change the sign of the second function, of that function g of t. So upon doing that, we've got this 3t plus 69. That doesn't change. And so here we have minus a negative 0.2t and minus a positive 13.8. That's just going to change the signs. It was negative here. We're going to change that to positive. It was positive here. We're going to change that to negative since we're subtracting. And combine like terms. 3t plus 0.2t is 3.2t. And 69 minus 13.8 is 55.2. And this is our new function. This is the function that projects the average number of legitimate emails sent and received per user per day. And I'm going to label this as a new function. Let's call that maybe h of t. So once I have this function, I can find the projected average number of emails, of legitimate emails sent and received in any given year. Right? So for example, right, if I wanted to calculate the number of legitimate emails in 2015, all right, then I would find the t corresponding to 2015, plug it into the function, and then evaluate, simplify to find how many legitimate emails I would expect. So I'll take my h of t, and I'll plug the t that corresponds to the year 2015. Now back up at the original, all right, we're looking at the years between 2011 and 2015. And we started with this restriction that t is between 1 and 5. All right, so it starts with 1, ends with 5. That's going to corresponding to the beginning and ending years. So t equal 1 corresponds to 2011. T equal 5 will correspond to 2015, right? T equal 2 is 2012. T equal 3 is 2013, so on. So since we're looking for the number of legitimate emails in 2015, that would correspond to t equal 5. So we'll plug 5 into t. And that will simplify into 71.5. 71 let's try that again, 71.2. Right, 3.2 times 5 is 17. 17 plus 55.2. Let me make sure that I have that right. 3.2 times 5 is 16. Excuse me, 16 plus 55.2 is 71.2. That's the number of legitimate emails per corporate user per day in 2015. All right, and we can look at one more example here while we're on the topic of applications. Apollo manufactures smartphones at a variable cost, where this function is v of x equals 0.000003x cubed minus 0.03x squared plus 200x. X represents the number of units manufactured per month. Now, it's also given that the monthly fixed cost is $100,000, and the total revenue from the sale of X smartphones is given by the function R of X is equal to negative 0.1x squared plus 500x, and this is up to 5,000 smartphone sales. Now, there's 3 parts of this problem. First, we want to find the total cost incurred by the manufacturing of X smartphones, then find the profit function, and then we want to find the profit when 1,500 units are produced and sold each month. Now, we're given the function for the variable cost, and then we're given the monthly fixed cost. The total cost function is the sum of the variable cost plus the fixed cost. Now, the fixed cost is maybe the monthly rent, right? This is some amount that you're going to pay no matter how many units that you produce, where the variable cost will change based on how many of those cell phones that are manufactured. So the total cost function, which we'll call this C of X, is the sum of V of X and the fixed cost, 100,000. So that would be the 0.00003x cubed minus 0.03x squared plus 200x. That's the variable cost plus the fixed cost of $100,000. That's the total cost function. All right, so now in this part 2, find the profit function. Now, the profit function can be found by subtracting the cost from the revenue. Profit is how much you have left over after you factor in the cost. It's the revenue minus the cost. And here we have a function for the revenue, and we've calculated the function for the total cost. So this profit function, which we'll call P of X, that is the revenue minus cost. And so this is negative 0.1x squared plus 500x minus, don't forget the parentheses, don't forget to distribute this minus sign when you're subtracting 0.000003x cubed minus 0.03x squared plus 200x plus 100,000. Right, and we said when we distribute this minus sign, it's just going to change the sign of everything inside the parentheses. Let me show this distribution, and then we will combine the like terms. All right, now combining like terms on it, and I am going to write this in descending order. So I've got my x cubed term that I'm writing first. I have negative 0.1x squared plus 0.03x squared. After combining like terms, negative 0.1 plus 0.03 is negative 0.07x squared. Then I have my like terms 500x minus 200x, which is 300x, and then the minus 100,000. This is my profit function. Now, once I have the profit function, I can answer a question such as number 3. What is the profit when 1,500 units are produced and sold each month? I can find that by simply plugging in, substituting the 1,500 into the x. I would suggest just putting this all entirely into your calculator, which is what I'm going to do here. Notice that I left off a 3 there. All right, once I put all this into the calculator, I'm just going to show you the simplified answer. You can check and verify that you get the same thing. You get a profit of 182,375 with a profit when we produce and sell 1,500 units. Let me go back and fix my number here. It should have been 100,000. My calculations, I was using 100,000, but a 10,000 there. Didn't want to mess anybody up. $182,375 for the profit is our correct answer.